Alright, we're going to look at section 10.7, which deals with area of sectors and segments in areas of circles. So we're asked on this one how much more pizza we have for 14-inch diameter versus 12-inch diameter pizza. And so we will look at area to do this. And so let's just sketch our circles. One has 14 inches, one has 12 inches for diameters, which is all the way across. Find the area with pi r squared for a circle. If my radius is, my diameter is 14, my radius is 7, and so I can use that radius to figure out the area of the larger circle. The radius of the smaller one is 6, or half the diameter, and then using pi r squared, I put in 7, and I get 49 pi. I'll leave it like that. And for the other one, I'm going to get 36 pi when I put 6 in there, so 36 pi. Now, I'm not done yet because it's asked for how much more. And so what I need to do is actually subtract, take the difference in areas. So this is why I left it in terms of pi. I get 49 pi minus 36 pi, which is 13 pi square inches. That's an exact answer. And you could approximate it by using 3.14 or the pi button on your calculator, whatever you want. You would get around 40.8 square inches more. For the next one, we're looking at a sector. And to do this, we have to take our central angle, whatever that is, over 360, just times the area. So it's just proportional to the central angle. So I have a diameter of 20, and then I have a sector that's 208 degrees. So it looks like that. It's larger than 180. And I'm looking for that sector, which means I need to have a radius of 10. And that's the piece I'm looking for, that shaded area. So the area of that sector is the central angle, 208 over 360, times the area of the circle, which is pi r squared, or 10 squared. And I could simplify it for an exact answer, but if I plug in my calculator, I get around 181.5 centimeters squared. For the last one, we're asked to find the segment, which means that we need to figure out a triangle, and we need to figure out a sector and subtract them. So that's what they do up here. They figure out the sector, they figure out this triangle and take the difference between them, and that gives us this orange piece of the segment. So if we sketch our picture, we have a 60-degree angle, central angle. I'm looking for the area of that segment, and I know that my sector is going to be 60 over 360. That's my central angle over all the way around, which is 360, times the area. And for the area, I need the radius, and the radius is going to be 12. So I take pi times 12 squared, which is 1/6 times 144 pi, or 24 pi. Now what I need is the area of the triangle. And so there's different ways you can do this, but it's a 60-degree isosceles triangle, which is actually going to make it equilateral as we do it. And to figure out the area of a triangle, I need base times height. So I draw in my height, and then that 12 gets split up into 6 and 6. And so area, I need to figure out that green piece. I need to figure out that height. This 60 gets split into 30 and 30. And now I have a 30, 60, 90 triangle. So I fill in what I know, 12 and 6. The side that is opposite 60 becomes the short side, which is 6, times the square root of 3. So I get 6 root 3. Now I'm ready to find the area of my triangle. So I get the area of the triangle is 1/2 base times height, 1/2 12. Right? The base of this whole triangle is 12. The height we just figured out to be 6 root 3, which gives me 36 root 3. Now I'm not done yet. All right, I'm up here at this point. I need to now figure out the area of the segment and subtract my two values. So if I subtract them, it's the area of the sector minus the area of the triangle, which is 24 pi minus 36 root 3. I can't combine those. I could factor some 6's out, but I could just plug it in my calculator as well and get 13.04 centimeters squared.